2.3, 2, 3. Is that right? Or is that backwards? One of the ways. Okay, let's go to it. It'll be fun. Okay, 2.3, graphing linear equations in two variables. So we actually sort of did that in the last section in 2.2. And they start you off with those same problems that they did in 2.2, but they have you, that we already did in 2.2, and then they have you graph them. And then they go on to coming up with, so they start you off by giving you half of the ordered pair, and then they have you do your own. And so I say, this is how you graph, is you want to find 3 solutions, which are ordered pairs, and you choose and compute. And we're trying to get something that falls on our grid. And we can relabel it and not count by ones, but if possible, I like to count by ones. And so when I do that, I like to put my my solutions in an input-output table, some people call them, or an XY table. That's good as well. This equation is really easy since it's solved for y, if you choose x's. And so my favorite x to choose by far is x is 0, because that's good on my arithmetic. And so this was my choose. And now I'm going to do my compute. So I don't get to choose what this value is going to be. I have to use the equation to see what it is. But it's not hard to compute it. Because I pick such a nice value, all I have to do is plug in x is 0 and do the arithmetic, and that will tell me what the y value is. So it's -1. Y is -1. And so sometimes people say, well, I chose both of those values. No, you didn't. You chose one of them and you computed the other. And so now I have one solution, and it says that I need 3. And so it really takes 2 solutions to create a line, is what it takes. But the third is a backup to make sure they're all collinear. If all 3 of your solutions are collinear, then you can, it's better chance that you haven't made a mistake. So it's a way of checking your work. So another good point to choose, and you get to choose anything you want. I wouldn't choose y because I'm lazy, and I'm going to show you why I wouldn't choose y here in a second. But the next point I'm going to choose is an x value, and I choose anything I want. And so I could choose x is 2. I could choose if I wanted x is -5. That would be okay. But remember, I'm trying to stay on my little grid here. And so I'm kind of looking at, well, what will the output be? Because I'm thinking about counting by ones and not having to count by anything else. I'm thinking about choosing 2. So this was what I chose for my second time. So I choose this. And now I'm going to compute. So y equals, so this was my work, right? It could be in my thoughts, or I could write it out. Y equals -3 times what? -1. We chose 2. You could have chose anything, but I'd like it to stay on the grid. And so, or relabel the grid so that it fits on there. And so this is -6. It helps you with your number sense, keeping it on the grid, that's for sure, -7. So I just barely hung on the grid, right? And you can kind of imagine that if I had chose 3, I would have gotten off this grid and had to renumber it. And so this is my work for that next one. And this was my compute, right? So I did that work. And so now I want to find a third point. And my third point is really for a checkpoint. And I can choose another x, and that would be a good idea. But for excitement and learning, because I want you to see that it's harder work, I'm going to choose a y, okay? I'm going to choose y is, and then I could choose whatever I wanted for y. So maybe perhaps I choose 7 for y. Why not, I say. That would be great, right? And so now this is what I'm choosing. And it would be better if I chose an X, I know, but we're just doing this for excitement, right? So I'm going to do the work to compute it right here. But just to be exciting and to show that it's possible, you get to choose whatever you want, just not something already in the list. So I'm choosing 7, that wasn't already in the list. And I'm going to put this in my equation. My equation is y equals negative 3x minus 1. I'm going to put in y is 7. I'm going to have to add 1. So see how it's more work. It's not just arithmetic. And so that's the reason that it really wanted to choose another x, right? So dividing by negative 3. And not only that, I get a fraction, right, as my answer for x. X equals negative 8 over 3. Now, x equals negative 8 over 3, for my graphing pleasure, when you get an improper fraction, I like to write it as a mixed number. And that's negative 2 and 2/3 is what that is, 8 over 3, because that's easier to plot. And so negative 2 and 2/3. Okay, and so you can see that my computing was a little bit more work than if I had chose an x value. So probably a better thing to have chosen here would have been to have chosen x is negative 2, perhaps, or chosen x is 1 would have been good. Or chosen x is negative 3, I think would turn out okay, and maybe on my grid. No, negative 3 is going to go a little bit off my grid. Okay, this one's pretty steep. So I'm going to plot these 0, negative 1. I don't have to label it because I am going to count by ones. Over 2, 1, 2, down 7. Over 2, negative 1, negative 2, and 2/3 is almost to negative 3. And then up 7. And there's my 3 points on my line. And you can see that they are collinear. If you make a mistake when you're plotting them, perhaps, or whatever, they won't be collinear. So I want to show you what it would look like. So we know that we're going to have an error there, because that was really right? And I'm changing it. A common thing people do is plot it backwards. So over 7, down to 1 and 2/3, like this. I do that all the time, and in fact, particularly if I choose y and then choose x. Because I usually choose x and then find y, I'll sometimes plot it backwards. And you see how this is making a triangle. And so that tells me that I have a mistake. Now, I don't know which point is a mistake. I only know that this one is the mistake because we know, I mean, you don't usually purposely make a mistake. And so what I would suggest you do if this happens to you, that you get a triangle, is that you first go and check that you plotted the points correctly. Then if you did plot them all correctly, that means one of them is incorrect from here, and then you plug in the x and the y and make sure that they're true, like we did in section 2.2. And they will not make a triangle and be plotted correctly and be correct in the equation. This is going to make a line. And so you know there's a boo-boo if it's not. And so when I check if they're plotted correctly, I would notice, oh, yeah, what did I do? I didn't plot those correctly. So it's kind of good. And you should get a ruler. And on my little grids paper that I have, some kind of ID works really well. Like the Bakersfield College ID works really well if you don't have a ruler, so you don't have to go out and buy a ruler or anything like that. You could use your Bakersfield College ID, or you could use your driver's license or something along those lines. Okay, so it's asking us to graph this equation. And when you graph this equation, you want to pick points smart. And so here, when I did this wasn't incorrect, but it makes it more chance for error when you get like a fraction in there or a mixed number going in there. And so you want to choose good points. And so x is 0 is a good point, and it's my favorite point. And see how well it's going to work in here, because 0 times 2/3 is going to be gone. So when I go here and I get my little table to store my 3 solutions, 0, the choice of x is 0 is almost always my favorite point. And so since I said almost always my favorite point, I'll show you when it's not my favorite point. And so here's the work I'm going to do. I chose x is 0. That was my choice. Y equals 2/3 times 0 plus 1. So y equals 1. People always ask me, do you have to show this work, or could you do that in your head? And the answer is, you can do it in your head. I show it because if I say when x is 0, y is 1, and I put it in the grid, about 2/3 of the class says, how did you know? And so, well, I did this work in my head. Well, I show you what work I did in my head so that you will know as you're learning what the work to be done is. Now, I would like to pick something that would get rid of the fraction. So I have 2/3 x. And so if I pick 1, then this will be 2/3 times 1, which is 2/3, and that didn't get rid of the fraction. If I pick 2, then this will be 2/3 times 2, which will be 4/3, and that didn't get rid of the fraction. But if I choose 3, right, if I choose 3 in there, the 3's would reduce with one another, and that would make a nice whole number. And then I'm less likely to make an error when I do that. So when you're choosing points, you want to choose good points. And so if you have a fraction, a lot of times choosing the denominator is a really good thing to do. So this is going to be x equals 3. So we would have y equals 2/3 times 3 plus 1. And of course this is 2/3 times 3 over 1, right? And the 3's cancel. That's why we chose it, plus 1. So this is 2 plus 1, which is 3, coincidentally 3, for our value of y, right? And so, and I showed every step. I maybe showed more than every step there. So now we have 2 points. Another good point to choose would be -3 would clear the fraction, and also 6 will clear the fraction because 3 goes into 6 2 times. So good points to choose when you have a fraction is multiples of the denominator when you have a fraction. So multiples of 3, 6, 9, it goes on, but also includes -3, -6, and -9. And I want to tell you, friends, 0 is in that list of a multiple of 3. It's counting by 3's, right? And so if you go backwards from 3, backwards 3, you get 0. And I already have 0 in my list. It's my favorite point. So now my choice are, should I choose 6 or should I choose -3? I don't want to choose 9 because it goes off my grid unless I want to rescale. And I'm kind of lazy, and since I have a lot of other choices that I could make without having to rescale, and I'd rather do that. So I'm going to choose, coin flip. I don't know, -3. If you say I would have chose 6, yeah, that's how people are, right? Always have to be contrary. I kind of like to be contrary myself too. So this is -3 over 1. So the 3's cancel, and so this becomes -2, because this is really 2 times -1 plus 1, which is -1. So that's my y value here. So -3, -1. And then I'm going to plot these. So over 0, up 1. Over 3, 1, 2, 3, up 3. And over 3, 1, 2, 3, down 1. And do they look like they're on the same straight line? If they don't look like they're on the same straight line, the first thing I check is how I plotted the points, because I make more errors doing that than I do on my arithmetic. And okay, but you can check whatever you think would be good first. Kind of get where you know yourself. Make sure, are all my points right? then check whether or not you plotted them right. I'm more likely to plot them backwards because I get to talking and chewing gum and thinking about banana nut muffins. And that's how it goes. Graph the line by plotting 3 ordered pairs. Is that the same line? Oh. That's the same line. Well, that doesn't seem very exciting. So I'm going to cross that one out. Cross that out too. How did that happen? I don't even know how that happened. I'm going to get another one out of your book. There was a gremlin. Something happened. Crazy, right? And I'm going to come here in 2.3 and grab us another problem. So I'm going to choose, instead of that one, I want to choose problem 28. I might even fix this on your guys' notes since I haven't put them up yet. My pencil's out of ink. Out of lead, I mean. I'm running pencils out of lead today, big time. This is my third one, and I've had to yell out to my son, oh, I'm going to pick 30 instead. And I think I am going to put it on your guys' deal. So this is number 30 that I'm choosing, and the equation is 3x minus 4y equals 8. So this equation is not solved for x, it's not solved for y. The ones that are solved for y are going to have a special name. And this one that has x and y on the same side of the equation has a special name. And some books call it standard form and some books call it general form. And at this moment in my time as existence as a human being, I don't remember if your book calls it general form or standard form. But either way, x and y are on the same side of the equation. So I'm going to choose some points. And I have to admit that 0 is still my favorite point. I can't help myself. And so when x is 0, this is going to be my work. This is going to be 3 times 0 minus 4y equals 8. So 3 times 0 is 0. So that's gone. That's why I like it. And then I got negative 4y equals 8. Well, that's easy to solve for y. All I have to do is one step, which is divide by negative 4. Divide by negative 4. So I get y equals negative 2. So that would be my work. And that turned out pretty lovely. Now I'm going to pick, when I have x and y, when I have general form or standard form, I like to pick y as 0 as my second favorite point. And it's going to turn out wonderful as well. Not as lovely as the other one did, but 3x minus 4 times 0 equals 8. So that goes away. So we have 3x equals 8. And that's pretty easy to solve too, because it's just one step, divide by 3. Now it made a fraction, 8 over 3, which is 2 2/3. But I'll deal with it. Now I've got 2 points, and you need 3 so that you have a check. And you could choose anything that you wanted as long as it's not already in the list. You choose anything for x, and you can choose anything for y. And some people who are pretty good with their numbers can sit here and think, what would I choose x to be, or what would I choose y to be, so that both x and y would be whole numbers. And on some of them, it's easier to choose that, and some of them, it's harder to choose, so that they're both whole numbers. I already got a fraction going in here. And so I might be able to cleverly think what would create a whole number. Like I'm thinking maybe 4 for x, because that will make 12. And when I get it over here, that might turn out to be nice. But you don't have to pick something nice. So I like to pick something nice if possible. But if not possible, then I just get what I get. So I got 12 here. So this does, because I didn't pick a 0, I already had 0, so I couldn't pick them. It is one more step. I'm going to have to subtract 12, then divide by -4. And see how I got lucky there and was able to come up with something that was going to divide nicely. That's going to give me +1, y equals 1. And so you can kind of sit there and think until you get a good one, or you can just get another fraction. So over 0 down 2, so I think I don't have to count by anything other than ones, over 2, 1, 2, and almost to 3, right? 2 and then up 0, 2 2/3 of the way. My dot's so big that it kind of handles anything going there. So over 4, there's 3, here's 4, and up 1. And they should look like they're on the same straight line. And they are. So I'm going to get in there and I'm going to draw my line through there. I'm going to keep my BC math looking good. Straight up and down. So for the next time that you turn in something like a lab or a test or whatever have you, you need something that will draw a straight line, like your BCID would work. If you don't have a printer, because I have this grid paper on my paper for you, but if you don't have a printer so you can't print the paper, then you're going to need grid paper as well. And usually you can get grid paper at Target or at Walmart, and so those kind of places. I know you can get it at the BC bookstore as well. Now they asked us to plot 3 ordered pairs here, and then I'm going to show you a shortcut. And so I am going to plot the 3 ordered pairs. This equation is like a selfish teenager. It only cares about one variable, and that's itself. It only cares about x, right? So you cannot pick x to be 4 because this equation says that x is -3. So that's not even a possibility. My favorite point to choose usually is x is 0. Well, that's not a possibility. It says x is -3. So that's what I need to choose for x, -3. And this equation is satisfied, meaning it's true, no matter what the value of y is, right? So if I pick x to be -3, and my equation is x equals -3, y could be anything. And in fact, if it makes you feel better, you could pick y first. And so if y was 0, then I go to this equation, and this equation says, yeah, I don't care. That means that x is -3, right? Well, what if y is 1? Yeah, I don't care about y. X is -3, right? And what if y is 2? Well, this equation says, yeah, I am satisfied as long as x is -3, right? So there's 3 ordered pairs, and I want you to notice that they have only the value -3 for x, and y could be anything. Could be so you could choose those values that I've chose or different ones. So over -3, up 0. Over -3, up 1. Over -3, up 2. And then they are collinear. They're on the same straight line. And so when I draw that straight line using my handy dandy ruler, you notice that that straight line is not slanted like this line is slanted, goes across, and like the other lines that we've drawn today. These were slanted going downhill. This one's going uphill, right? This line is, this one's going uphill. This one's straight up and down. And this is called a vertical line that's going up and down. And I want you to notice the equation. The equation is x equals -3. And the reason I want you to notice that is because a really common error, this is the x-axis, remember, and this is the y-axis. is people say because the equation only had x in it, that it looks like the x-axis. I hear that all the time. But when you look at it, here it is. It does not look like the x-axis. The x-axis going here, right? It looks like the y-axis is what it looks like. It's vertical like the y-axis is. And so it's kind of counterintuitive because since it has x, it seems like it would look like the x-axis, but it doesn't. It's saying that all of the points for y are to the side -3. And if you do to the side, -3, they're all going to be the same distance from the y-axis. So all of my solutions look like this. X is -3, and then any number could be in here for y. So y could be 15, y could be 37. Have to rescale, huh, if I wanted to draw them on there, but it would be possible. Okay, so graph each of the following lines by plotting 3 ordered pairs. So y equals 3. And so you're noticing that this equation doesn't have x in it. So I could pick my favorite point, which is x is 0. But this equation doesn't care. It says, yeah, y is 3. Right? No matter what x is, y is 3. And so it has that same thing that we had on the other one, in that I can choose anything. All of my solutions are going to look like y is 3. And you could have any number in here for x. So over 0 up 3, 1, 2, 3. Over 1 up 3. Over 2 up 3. And you notice that it is making a horizontal line. So this line is called horizontal. Whoa. And so our story is, just to fix it up, horizontal lines, their equation looks like y equals some number. Your book says y equals b, where b is any number. And vertical lines look like x equals a number. Your book says x equals a, where a is any number. And slanted lines, those are ones that go up and down, go uphill or downhill. So this one's going uphill, have both x and y in them. So every slanted line has x and y, and then a slanted line. X and y, and then a slanted line. So that's true. And you can go back and you can look at others that we have done and see that that is the case. And so that is the end of 2.3.